with 5.1, the first lesson you're going to have in chapter 5, we're really going to do a quick introduction of polynomials and in behaviors, and we're going to graph. Okay, so there's some exploratory examples for you to figure out in behaviors of polynomials after we do the little introduction. Okay, so a polynomial is something you've already done before. So if you've ever seen x plus 4 or x squared minus 7x plus 12, those all fall under the category of polynomials. Okay, you've got monomials, which is one term. A binomial is two terms added or subtracted together. Trinomials, three terms added or subtracted together. And this is what you would have factored in chapter 4. So this should be something you recognize already. Okay. You would have also factored binomials with the difference of two squares, if y'all remember that, something like x squared minus 25. So that's not new. Okay. Once you get past three terms added or subtracted together, then we just call it a polynomial, okay? And it could be any term. So what makes it a polynomial are a few things. I used to ask you to identify if it is or isn't, what degree it is. I took that out because it's really not beneficial to what we're leading to, okay? It's good to be able to identify it, but it's not going to make a difference, really. So for it to be a polynomial, your exponents have to be whole numbers. They cannot be variables. Your variables cannot be in the denominator of anything. And then your coefficients have to be real numbers. Okay, so if you look at it and it looks normal, it's a polynomial, basically. What is that? That's what it's saying. So what you need to be familiar with, though, is standard form of a polynomial. Okay, so standard form is your polynomial in descending order of your exponents. Okay, so you go from your highest exponent down to your constant. Okay, so this x squared minus 7x plus 12 is standard form of a trinomial. Is it still? Yeah. The whole. Okay. So when you're doing, especially 5.2, when we are doing our operations of polynomials, you're going to want everything in standard form. Okay. So the degree of a polynomial is based off of your highest exponent in standard form. Okay. So if you just have a first degree, that's linear, second is quadratic. Y'all know that so far. If you have x cubed, that's a third degree, and that's cubic. Fourth degree is quartic, fifth degree is quintic. After that, we just say seventh degree polynomial. We don't use any like actual vocabulary for that. Okay. So again, the degree of the polynomial is going to be your highest exponent, and you're going to really look at that when we do in behaviors, and you're going to look at the leading coefficient. Okay, so what we look at is when there's only one variable. So you have x throughout the whole polynomial. If you had x and a y combined in one term, then the degree of that polynomial would be the greatest sum of those exponents. I don't give you that anymore, so you don't have to worry about that. Okay. Another thing that I always say too is if you're confused on what the degree is, if you think about temperature and the degree symbol, it's in the same spot you would write an exponent. So if you want to put that together in your head, kind of correlate that, you can. It's always referring to your highest exponent of your polynomial. Okay. Now, with your end behaviors, that is basically your function's growth as x approaches positive and negative infinity. Okay. So we're going to look at that graphically, and we're going to look at different types of polynomials and what the end behaviors are for that. Then we're going to also look at, if I just give you a function and you don't get to graph it, how can you know what the end behaviors are? How can you predict that? Okay. So it's going to be based off of two things. It's going to be based off of your degree and the sign of the leading coefficient. Okay, so when you have in behavior, I'm going to write the template. It's two segments. Okay, I'm going to write it and then I'm going to explain it. So I can copy it down. You got f of x with an arrow, and that arrow is read as approaches. So f of x approaches blank as x, and then you have another arrow. So x approaches negative infinity. And then I've got f of x arrow. So f of x approaches blank as x now approaches positive infinity. So you're looking at just two things for end behavior. Okay, so if I am thinking about this statement right here, x approaches negative infinity. If you think about an xy grid, x approaches negative infinity would be on what side? The left. So when you read that, you have to think the left side of your graph. Okay, so x approaches negative infinity is just referring to the left side of your graph. Okay, x approaches positive infinity is going to the right side. Now, in behavior, you're only looking at the two ends of your graph. I'm not looking at what happens in the middle. Okay, so I'm looking on the left and the right. Where is it on the left? Where is it on the right? Okay, now f of x is the same as what? Y. Okay, f of x is the same as y. What direction options do I have for y? If x is left or right, y is up or down. So you're telling me the function is either going up or it's going down on the left and the right side of my graph. Okay, now up would be positive infinity and down would be negative infinity. Okay, the reason I put a blank here is because that positive and negative infinity is the only thing that's going to change each problem. Everything else is going to be as x approaches negative infinity and as x approaches positive infinity, because that's your left and that's your right. Okay, do we understand what this means? Okay, so you're going to rewrite this over and over. Okay, and that just is what it is. That is part of end behavior. Okay, so that's your template. The only thing that changes is this. Okay, the up or the down. Okay, so what we're going to look at is the different types of polynomial functions you might have. I don't think I go any higher than this, so I just did the 4 families. And we're going to look at the degree and the leading coefficient of each of these types. Okay, so if I have a quadratic function, that is your x squared that you've already done in chapter 3 and chapter 4. Okay, we graphed in chapter 3. So if I have y equals ax squared, a could be anything. Okay, but right now we're considering it to be positive. Okay, so my leading coefficient I abbreviate with LC. So my leading coefficient for this example that correlates to this first graph is positive. Okay, because I don't have a negative sign. All right, my degree, remember, is your highest exponent of the polynomial. So if it's quadratic, my degree is 2. That is an even degree. So when we start analyzing your leading coefficient and your degree, I'm thinking positive or negative for leading coefficient and even or odd for degree. Okay, so for quadratic, this example, if I copy down my end behavior template, f of x approaches blank as x approaches negative infinity, and f of x approaches blank as x approaches positive infinity. When it's a graph, you can just look and you can tell where your function is going. Okay, so if you're visual, this should be easy for you. If I'm looking on the left side of my graph, where's my function going? Up. So what would I put here? I would put my positive infinity. Because remember, you're looking at the left and then you're looking at the right. Okay, your left is where it starts, your right is where it ends. Okay, so if I'm looking at the right, where's my graph going? It's also going up, so I would put positive infinity there as well. Okay. Now what happens to my function for my graph now to be flipped? What do I need? A negative. So this is now y equals negative ax squared. So now my leading coefficient is a negative, but my degree is still going to be x squared, so my degree is still even. Okay, so when I do my end behavior, f of x approaches blank as x approaches negative infinity, and f of x approaches blank as x approaches positive infinity. So on the left side of this graph, where's my graph going? Down, so that would be negative infinity. On the right side, where's my graph going? Also down, so negative infinity. Okay? Do you understand the end behavior for quadratic? Visually, it's very easy. Okay? You don't have to overcomplicate that. So for cubic is when you're looking at y equals ax cubed. This is a simple cubic graph. Okay? So here, for this first graph, my leading coefficient is positive. And since it's cubic, I have x cubed. My degree is at even or odd? Odd, because my degree as a number would be what? 3. Okay? So when I do my end behavior, f of x approaches blank as x approaches negative infinity, and f of x approaches blank as x approaches positive infinity. Okay, on the left, where's my graph going? It's going down, so what would I put? Negative infinity. On the right, where's it going? Up, so f of x approaches positive infinity. Okay? Now what happens between this graph and the next graph? It's flipped. So this is an example if you had y equals negative ax cubed. So now my leading coefficient is negative, and my degree is still odd. Okay, so for my end behavior, if I'm looking at the left of my graph, where's my graph going? Up, so that would be what? Positive infinity. And if I look at the right side of my graph, where is it going? So that would be negative infinity. Okay? So a lot of people get hung up on the way it's written and what does x approach negative infinity mean, but if you just think about on the left and the right, it makes it a lot easier. Okay? If you separate left, right, up, and down for your parts. Okay, so for quartic is if you have y equals ax now to the 4th power. Okay? So my leading coefficient, I'm back to having a positive leading coefficient. And what is my degree, even or odd? Even. Because quartic is a 4th degree function. Okay? So when we do our end behavior, f of x approaches blank as x approaches negative infinity. And f of x approaches blank as x approaches positive infinity. What happens on both ends? They're both going up, so they're both going to be positive infinity. So what do you think I'm going to write y equals what for this next graph? Negative a x to the fourth power. So now my leading coefficient is negative, but I still have an even degree. So now what should I have in these blanks? Negative infinity. Do we understand that? Okay. So for quintic, that is if we have y equals a x to the fifth power. Okay. So here I have a positive leading coefficient, and now my degree is odd. So what do you notice about the end behaviors of that? F of x approaches blank as x approaches negative infinity. What's happening on the left? Going down. So that would be negative infinity. And then f of x approaches blank as x approaches positive infinity. Where's the right side going? Up to positive infinity. Okay. Now, just like y'all noticed on cubic, it flips with quintic. And so this would be y equals negative ax to the fifth. Now I have a negative leading coefficient, and my degree is still odd. Okay? So if I have my end behaviors, what happens as x approaches negative infinity? It's going up to positive infinity. And then what happens as x approaches positive infinity? It's going to go down to negative infinity. Okay? This x approaches positive and negative infinity, you will see again. Like if you do limits and stuff in calculus, that pops up. Okay? So before you flip it to the next thing, I want you laying your two papers flat to where you can see all four families of your polynomials. And I want you to discuss with your partner, and if you're someone who's by yourself, you can talk to the people next to you or in front of you. But I want you to see if you recognize anything that happens as a pattern. Maybe do you recognize a pattern? Do you recognize anything if you're looking at all four together?
It seems like the odd ones.
Okay, so I heard the same thing. I heard y'all's discussions a little bit more than my other period, which is great because y'all were kind of all on the same path. What are you noticing about the evens? What's the same? Your sums. Okay, if you look at quadratic and quartic, it's hard for me to put it on my screen. But if you look at that, with quadratic, we knew if it was a positive, it was opening up. We knew if it was negative, you would open down. It's the same thing for quartic. So your ends of your graph will be facing the same direction. Does anything else, what do you notice about, so I kind of said it just a second ago. your leading coefficient and those end behaviors with just quadratic and quartic. It's the same sign. Your leading coefficient is telling you where it's going. Okay? Now what happens with odd? It's so hard to put this together.
They're opposite.
For y'all to see. Odd is opposite. If you didn't recognize that, your ends of your graph are going in opposite directions. Okay? I'm just going to go to print it because it's just too hard to put on the screen. So, what do you notice regarding your leading coefficient? Compare that to either your graph or your end behavior. It's the second, which is the right side, which is where your graph ends. So your leading coefficient tells you where your graph ends. The same thing with even, you just don't have to think about it that way because even degrees go the same way no matter what. So with odd degrees, whatever your sign of your leading coefficient is, that's where your graph is going to end. So it starts in the opposite direction. Okay? So the next page kind of summarizes everything up to show you that. Okay? So you could have x to the 23rd power and still predict where those end behaviors are, just knowing if your degree is even or odd and if your leading coefficient is positive or negative. It doesn't matter if you know what that graph looks like. You could tell me where they end and begin. Okay? So the key thing is to know that your leading coefficient determines where your graph ends. So that's your x approaches positive infinity. That's what I mean by where it ends on the right side. So your leading coefficient determines where the graph ends. Your degrees are going to tell you if they're going to be the same or if they're going to be opposite. Okay? So if it's odd, they're opposite ends. They go in opposite directions, your signs will be opposite. If it's even, they're the same. Okay? So what we're going to look at is if I give you a graph and I'm not asking you to tell me what the function is, and we're not copying the function down. I'm just giving you a graph, and I want to know, can you describe the degree and leading coefficient? So what I mean by that is, could you tell me if the degree is even or odd? Just based off of the way the graph looks. And is the leading coefficient positive or negative? Okay. So if I'm looking at example 1, what can you tell me about the degree?
Oh wait, it's odd.
It's odd. How do you know that? Because they're opposite directions. You don't have to overthink it. If they're opposite, it's odd. What do I know about my leading coefficient? How do I know it's negative? Because that's where it ends on the right. It's very simple. Okay? Now what about number 2? What could you tell me about my degree? It's even because they're both going in the same direction. Now, them both going up tells me my leading coefficient is what? Positive. I could have spelled that out. I don't care if you spell it out or put the sign. Okay, just make it clear so I'm not guessing. If I have to guess what it is, it's wrong. Okay? So now we're going to do it without a graph. Okay, so we're going to describe the end behavior of the graph of the polynomial function by completing the statement. And this is just the basic f of x approaches what as x approaches negative infinity, and f of x approaches what as x approaches positive infinity. Okay, so our first function is f of x equals negative 4x to the 5th minus x cubed plus 7x squared plus 2x plus 11. Okay, so what you look at first is it in standard form? Do you go from your highest exponent down to your constant in descending form? Yes. So algebraically, when you're looking at a function, your degree and your leading coefficient, as long as it's in standard form, come from your first term. I don't care what happens afterwards. That first term determines my mean behavior. Okay? So I'm going to copy down my statements. F of x approaches blank as x approaches negative infinity. And f of x approaches blank as x approaches positive infinity. Now I need to know my leading coefficient in degree to tell me or to help guide me. Okay? So my leading coefficient, is it positive or negative? What is your leading coefficient? By -4. Okay, so you have to know your terminology. So leading coefficient is your first coefficient. Okay, so that's negative. My degree, is it even or odd? It's odd because it is a fifth degree polynomial. Okay, so what does that tell me? It's opposite. So one's going to be plus, one's going to be negative. Well, how do I know? What's what? My leading coefficient tells me.
Your leading coefficient is
right,
negative, so that means your positive infinity one on the bottom would be a negative infinity.
Okay, so my leading coefficient is negative, so it tells me we're in. So that means this second one on the right, my graph will go down. So that means it has to start in the opposite direction, which is the positive infinity. Good job. Okay, y'all understand that without graphing? You're not going to get a graphing calculator on that section. Okay, so the second example is f of x equals x to the fourth minus 11x cubed minus 5x squared plus 3x plus 1. I'm going to go ahead and also write my statement for my end behavior. Is that function in standard form? Yes. So my leading coefficient in degree come from my first term, which is just x to the fourth. So what do I know about my leading coefficient? It's positive. What do I know about my degree? It's even. You do not have to write this over to the side if you have this concept down. Okay, this is just for those who might still need it. Okay, it doesn't hurt to have it. So what does this tell me?
They're both positive infinity.
How do you know they're both that way?
Because it's even.
They're even, so even means they're going to end the same direction. My leading coefficient tells me it should be positive. Okay? So then example 3, we've got f of x equals negative 5x to the 6th plus 10x to the 4th plus 7. I want you to do that one. Okay, what do you get?
Both negative infinity.
Why?
Because your leading coefficient is negative and it's even.
So even means they're the same. How do we do?
Good.
Good. Do we understand the concept? Can we not do example 4? Fantastic. Okay. Graphing the polynomials is where you're going to have your graphing calculator for the test. Okay. So, what it's going to say is graph the function, state the zeros, make a table, describe the end behavior of the polynomial, and state the domain range. We're also going to look at a local max and min. It's not in the instructions, but you're going to need that to be able to make the full curve of some of these polynomials. Okay. So, your first example, f of x equals negative x cubed plus x squared plus 3x minus 3. Okay, once you have that down, we're going to use the graphing calculator. If it's not already cleared, go ahead and clear it, Doc B. You should not be in documents. You should be in the scratch pad when you're graphing. So if you just hit this calculator button twice, it puts you where you need to be. Okay. So then everyone has your F1 of X up, right? Some people had it missing. So if it ever does that, you can hit the tab and it will pop back up. Okay. So what you're going to type your function, negative X. If you don't know how to get the cubed, you can hit the little caret button next to X squared, and that raises you to an exponent. Okay. Everyone's got their graph? We're getting their graph? Should look like mine. So what we're going to do first is find our zeros. Okay, to find the zeros, you're going to do menu 6, enter. Okay, so menu 6 is what we're going to do everything out. Okay, and then it's already at 0, so you press enter. Once you do menu 6 enter, you should have a dashed black line that pops up. Does everyone have that? Okay. So what you're going to do is you're going to use this middle little scratch pad, and you're going to scroll that all the way to the left of that first x-intercept, because your zeros are your x-intercept. Okay? Zeros, root solutions, x-intercepts are all the same thing. Okay? Once you get it to the left, you're going to hit that middle button, kind of like an OK button. You're going to hit that, and it changes the lower to your upper bound. And if you move your finger across that scratch pad, you should have a gray area. Once you cross that x-intercept, it should pop up a point and the word 0. Did y'all do that? Okay. You can press the center button like OK again, and it will leave that point there. Okay, so everything in this section we're going to round to the 10th place. So one place behind the decimal. So if it's a negative 1.730, what am I going to have on my paper? Negative 1.70. Some of y'all have been off on your rounding in the past. So if it's 5 or above, it rounds up. Other than that, it stays. Okay. Now, if I leave it right here, it's going to get in the way. Okay. So I'm going to show you, if you hover over that, you see how you have an open hand? If you look at your middle button, there's another hand, and it looks like it's closed. So if you hold that middle button down, that hand will close. That means it's grabbed it. Okay. And I can move it wherever. And I press the center button to release it. Okay, so to move it, you hold your center button down till it closes the hand, move it wherever you want, hit the center button again, and it will release it. Okay? Y'all do the next X, try to get the next X intercept.
How do you just gives you like 1 at a time? Wait, how do you know what it is to go? Like, how do you know? Like, how do you know how to get this? Like, I know it's like right there. It's like, how do you know? Okay. Oh, you know, like, it's the other first.
There you go.
Do it again. How do you know?
Does anyone else have issues with theirs?
Nah, I really like that stuff.
This isn't
What's your second zero?
It's just like a
One,
thing to like show you.
Should be 1 0.
Your boundary line.
and then the third one is 1.7.
On like each side of the graph.
Yeah. The third
It shows you
one,
everything inside the graph.
1.70.
Inside the two.
Are y'all able to get all that? Because when it comes to your test, I'm not telling you how to do it.
I got it.
Okay?
Mini
Now-
6 enter.
Mini 6 enter. Now, see how it makes a curve down here? And then you also have a curve up there? Okay, when we did parabolas, we had what looks just like that. And this would be called what? Do y'all remember? The vertex. Now, if I'm looking at just this point, would it be a max or a min? Min. Now, with a parabola, it was your absolute lowest point for it to be a minimum, or your absolute highest point for it to be a maximum. Now that you have more to this graph, this is just called a local minimum and a local maximum. Okay? So we still need those points, though, to build our full graph on our paper. Okay? Because that's going to help us with our range when we have to do domain and range. Okay? So to find your max and min, you're going to still do mini 6. But you'll have to choose either 2 or 3. Okay? So if I'm finding my minimum, I'm going to do mini 6 2. And I get another dashed line. I'm going to do the same steps that I just did. Okay? But I'm going to go around the minimum. So I'm going to move that dashed line to the left of that little minimum curve. Press the center button. Go all the way, drag it until the point on that minimum pops up. Press the center button. Do you get the same point? Okay. What's my minimum? 4 point what? 3. Good.
Yeah.
Okay, then you're going to do the same thing for your maximum. Do y'all understand your steps? Okay. So menu 6, and then you're going to hit 3 for maximum. You're going to go to the left of it, and then scroll till you get the point. Now what's your maximum?
1.4 and then 0.4.
Good. Okay, I don't have any other curves. If I had another curve, I'd keep doing it. Okay? Now we need to build our table. So to get your table, do y'all remember how to do that from Algebra 1? I know y'all.
Hold on.
Control T. Okay,
Control
with
T.
the control, you don't have to hold it down like you do a computer. Just hit control, and then your T is towards the bottom.
It's Control T, by the way.
Okay, so for your table, it's control T.
Control T.
I'm telling y'all though, I'm not going to answer it. If you come up to me on your test and ask how do I get the table, I'm going to say, I don't know. That's why I'm writing it down. Okay? Now, what you need to include in your table, all the points you can, including the ones we just found. Okay? So negative 324 clearly is not going to fit on my table. On my graph. If you want to put it on your table so you know just how high it's going, so you make a good graph, then that's fine. But you can start with that negative 2, 3. And then before you do the negative 1, negative 4, you have to also include the points we just found. So I'm going to have negative 1.70. Then my negative 1, negative 4. And then before I go to 0, I need to have my negative 0.7, negative 4.3. Then I can have 0, negative 3. And then 1, 0. And then I should have my 1.4, 0.4. And my 1.70 before I get to my 2, negative 1. Y'all follow me on how I'm including everything? Okay. And then 3, negative 12 just slightly goes off my graph. So I can still include that. Okay, so then we're going to plot those points. With your decimals, just get as close to that as you can. You can estimate it. Oh, yes. Okay, so now we're going to look at domain and range. Okay, so your domain is your set of x values for this function. So you're going to look left to right for domain. Okay, when you're looking at the left, do you have a set cutoff point or do you have an arrow? An arrow. So I don't have a set boundary. Okay, it goes on forever to the left. On the right, do I have a boundary? No. So if I don't have a boundary left or right, what do I put for my domain?
Positive infinity, negative.
Negative infinity to
Negative.
positive infinity. All real numbers. Okay. Now for my range, that's your y, so you're going from bottom to top. Always go bottom to top, not top to bottom. Okay. So look at your graph. Do you have bottom or top boundaries?
Yes.
Or do you have arrows?
Arrows. Yeah, arrows.
Arrows. So I don't have boundaries. So my range is also negative infinity to positive infinity. It won't always be that case, but it happens to be the case for this. Okay? Now, I want you to do your end behavior. Oops. So your end behavior, as x approaches blank, as x approaches negative infinity, and f of x approaches blank, as x approaches positive infinity. You can either use your graph or use what you know about the function to figure that out. Okay? As x approaches negative infinity, where's my function going? Positive infinity. As x approaches positive infinity, where's my function going? Negative infinity. Okay? You understand what to do for graphing. Okay? So instead of doing 3 examples of graphing, I'm just going to do one more. Okay? Because I feel like it's repetitive. So our next function, we're going to do f of x equals negative 2x to the 6th plus 3x squared minus x plus 1. Okay, so once you get that copy down on your calculator, you can just press Doc B and it will clear everything you just did to start from scratch. So you'll type your negative 2x to the 6th plus 3x squared minus x plus 1. Now I'm going to move that equation because I don't want it getting in the way of those maximum curves. So to find our zeros, we do menu 6 enter. Scroll to the left of that first x-intercept. Move it over through the right. And what is that round to? Negative 1.20. Always list them as ordered pairs. And then find your second x-intercept. What's your second x-intercept? What is it? 1.10. Okay. Then when you do your max and mins, how many are you going to have to find? If you're looking at your graph, how many maxes do you have?
2.
And how many mins do you have?
None.
1.
1.
So you have a max and it comes down to a min and then it comes up to a max. Okay? So menu 3 for my first one. And what is that going to round to? Very good. Negative 0.9 and 3.3. And then I'm going to do menu 6 and I'm going to do the minimum. And that rounds to very good. 0.2 and 0.9. And then menu 6, 3 for my last max. Which is
0.8.
very good. 0.8 and 1.6. Okay. Some of y'all I can see are not doing it as I do it, and that is not the purpose of these notes. I don't need to do this. Okay. So, our table. How do I get to my table?
Control T.
Control T. If you look at your table, it's a very large jump from -1,3 to -2, -113. I know -113 isn't going to go on your graph, but putting it in your table so you know just how far up it's going so you don't make it a wide graph could be helpful for you. Okay, the accuracy might be good for you to put. So -2, -113, just to know. You don't have to, but it just might help you. Then before I do -1, I've got -1.20, and then my -13, and then I have -0.9, 3.3, then 0.1. I have 0.2, 0.9, and I have 0.8, 1.6. Then I have 1.1, 1.10, and then that 2, -117. Again, if you want to put it in your table just so you know how far it goes, you can. Okay, do we all have it graphed? Okay. What would my domain be for this function? Negative infinity to positive infinity, because I do not have a left or right boundary. Will that domain change? A lot of y'all shook your head no. Why not? regardless of the function I give you, that domain should be all real numbers every time. Because what should you always have on your graph? Arrows.
Arrow.
If you don't put an arrow, you're making it a discrete graph, which is totally different than a continuous function. That's why I count off if you don't put your arrows. Okay, so because you should always have arrows for a continuous function, that domain will always be all reals. Your range will not always be all reals though. Okay, your range, look at this graph. I want you to try to come up with a range. Talk with your partner. See if y'all can come to an agreement on what the range should be.
Huh?
Oh, yeah, I got roasted on my video. So much more. Low.
Okay, what's your range? What do you think it should be? If your range is bottom to top,
Because it's a circle. It's a dot.
what's on the 3.3? Who got that? Good.
Grace.
Okay, so for those who didn't, you look at the bottom. I have arrows going downward, so I do not have a bottom boundary. I always start at negative infinity and work my way upwards, so it's least to greatest. Okay. I hit a maximum at that 3.3. That's why I have you find that, so you have an accurate range. Okay. So our end behavior, what do you know about those? They're both negative infinity. Okay? Are we good with graphing? Okay, do we have any questions? Okay. We do not have a quiz over this.